Hey guys, and welcome to Chapter 4. We're going to start with Section 4.0, which is actually not in our book, but I have included this because I want us to review domain and range of function graphs. Now, so our learning target today is I can determine the domain and range of a function from its graph. Before we start doing that, let's review what domain and range are. So if we have some function f, which of course we see as f of x. X would be our input value, right? And our output is that f of x. Now, those two things, those two terms, input and output, are what make up our domain and range. So the domain of f is the set of the input values, which are our x values. And the range of f is the set of output values, which are our f of x or our y values. Now, when we think of the graph, when we look at the graph and try to find the domain, we think horizontally. We think how far to the left is the graph going and how far to the right is the graph going. So we're doing our x values there. And then when we think of range, we think how far down is the graph going and how far up is the graph going with our y values. All right, let's get to it, but I just want to remind us of what inequalities look like, because that's how we're going to express our domain and range. So remember the inequality signs look like alligator mouths, kind of. These first two signs I'm drawing right here are my less than and less than or equal to signs. So if you need to put these on there so you don't forget how they work, please do so. When I reverse the way they are written, these are greater than or greater than or equal to. And every time I do this, I will explain the signs and read them for us. Okay, we're going to start off with letter A. It is the linear function f of x equals x plus 1. So it's been graphed for us. And so we're just going to look at our graph and determine the domain and range, thinking like I have in these boxes, thinking left to right and then down to up. So this is a line. And something great about lines, or something we all know, is that there's arrows at each end. When we have arrows on any graph, we know that that graph goes on forever. In fact, we can't draw the whole thing. That's why we have arrows there. And we have to remember that in the coordinate plane, we can't draw the whole thing in that either. So I have the x-axis here, and there's an arrow at the end. Well, where is that arrow pointing? That arrow is pointing to positive infinity. And then the arrow over here on the left side is pointing to negative infinity. Similarly, on the y-axis, my y values go up to positive infinity and down to negative infinity. It's very important to understand these symbols and terms because a lot of times graphs have arrows, and that means that they go on forever, so we have to use the positive or negative infinity signs, or both of them. So linear functions are very special in that they go on forever in every single direction. So if I would take a look at my x values from left to right, I'm first going to just start kind of in my origin and say, well, how far to the left does my graph go? Well, there's an arrow here. That graph's going to keep going. Of course, it's going down, but it's never going to stop going to the left. So it's going all the way to negative infinity. And then if I think to the right, again, there's an arrow here. It's never going to stop. So my domain is it's covering my entire set of x values, which sometimes you might say all real numbers. But since we're using inequalities, we're going to use what I call a sandwich inequality and make a little x sandwich. It's going from negative infinity. So I'm going to say negative infinity is less than x, which is less than positive infinity. So x is between negative and positive infinity. That means it covers all x values. Now, thinking about the range, I'm thinking up and down. Now, this might be pretty simple because remember we have arrows, okay? So I'm thinking this end, doesn't it go down forever? And then this end, doesn't it go up forever? So my range is very similar to my domain in that it is going from negative infinity, which is less than y, which is less than positive infinity. So both my domain and range in this linear function are not bounded at all. They go on forever in both directions. So we cover all x values and all y values. So I hope that we can see in the next example B, this linear function again has arrows at both ends. Now granted it has a negative slope, but that does not make a difference in what x values and y values we are covering. So x values, I'm thinking, how far left is this graph going? Well, this arrow right here ensures that it's going to keep going, and it is moving to the left. How far to the right is this graph going? Well, this arrow right here ensures that it's going to keep going, and it's going forever to the right. So for my domain, again, it is just like the last one. Negative infinity is less than x, which is less than positive infinity. In my range, you can see we are going to go down forever and up forever. So it is also going to be negative infinity is less than y, which is less than positive infinity. And I do want to give you a little hint. Any linear function that has a slope other than 0 is going to have these same domain and ranges. Okay, so let's move on to a different function. I've got two quadratic functions here. Now we're familiar with these. These are parabolas. Parabolas have a minimum point or a maximum point, which is called the vertex. Now the fact that the one here on the left is a minimum gives us a very big hint that my y values do not go on forever. In fact, that's the lowest y value my graph hits. What is that value? Remember, our parent quadratic function right here we should be familiar with has a vertex at 0, 0. So the y values actually start there at 0, and they go up. We can see there's arrows on that parabola forever. So my range starts at 0 and it goes up to positive infinity. Now, something special about this point, 0, 0, it is part of the graph. So I am going to put, when I write this for my range, 0 is less than or equal to y, which is less than positive infinity. I have the or equal to because that point is on the graph. Okay, my graph touches the point 0. The reason I never put the or equal to sign next to the infinities is because infinity is not a number, it's an idea, so you can't be equal to it. All right, so I started with range because it was obviously different than our lines, right? It's restricted. But domain, a big hint about domain is I've got arrows. Arrows mean this is going to go on forever. That means this parabola is going to keep getting wider and wider and wider. It's going to keep getting wider to the right and keep getting wider to the left, which means our domain is also negative infinity less than x, which is less than positive infinity, just like our lines were. And that's going to be true for every parabola. So when we look at D, we see that we have reflected this parabola downward. So it does affect our range because now I'm in negative y territory, but it does not affect my domain because I'm still going to keep getting wider and wider. So my domain is the same as my previous 3 examples, actually. So negative infinity is less than x, which is less than positive infinity. But my range, that's where we differ. Now my vertex is a maximum point. Okay, so that is the highest y value that my graph is going to reach. So actually, when I think about range, I'm thinking it stops here at 0, but it goes down all the way to negative infinity. And so I need to write, when I write the range, start at negative infinity is less than y, which is less than or equal to 0, because that is the highest point on the graph. And we always want to put the lowest on the left, lowest, and the highest on the right. If we do these sandwich inequalities all the time, it's going to make it easy. Okay, now let's move on. I have an absolute value function. It's very similar to a parabola. The only difference is it's pointy, right? So it looks a lot like our letter C up here because there's arrows at both ends, and there is a minimum point. So I hope we've gathered when we have arrows at both ends, we're going forever left and right. So my domain is going to be, again, covering all values from negative infinity to positive infinity. But my range is different. I have a minimum value right here. That looks like the 0.03. So I'm starting at 3, but I'm going up forever to positive infinity. So my range is 3 is less than or equal to y, which is less than positive infinity. Okay, moving on to my next one is a cubic function. F of x equals negative x minus 3 quantity cubed plus 4. So just a little review. Remember what these things mean. A negative in front is a reflection over the x-axis. Subtracting 3 means we're moving right 3. Whoops, that should be a 3, not a b. And this up 4 at the end, remember our k value? Up 4. Okay. So if we can see, look, if we would start here and go right 3 up 4. Oh, cool. And we reflected. All right, let's look at this one. Domain, x values. So obviously right here is the center of our graph. And to the left of that, I have an arrow. So that means it's going forever. It's getting wider to the left. To the right, I have an arrow as well, which is getting wider and wider to the right. So my domain covers all x values. Negative infinity is less than x, which is less than positive infinity. Let's talk range. Up and down. Now, there are arrows on both ends of this graph. It's different than our previous two with the parabola and the V-shaped absolute value because those arrows are both going in the same direction. These arrows are going in opposite direction. This one's going down, this one's going up. Very similar to our lines, right? So this cubic function actually has the same domain and range as our linear functions did because it's going all the way to negative infinity, less than y, and it's going all the way up to positive infinity. All right, let's look at this quartic function, a degree 4 function. F of x equals negative x to the 4th plus 7. I'm going to speed up a little bit because these are starting to look pretty familiar. This looks kind of like a parabola, just a little flatter at the top. I see I have a maximum point, so that's going to affect my range. However, I have arrows on both ends, so when we ever receive that, our domain is going to go on forever in both directions. So my domain, negative infinity, is less than x, which is less than positive infinity. My range is going down forever, right? But it's stopping at this maximum value of 7. So my range is going from negative infinity is less than y, which is less than or equal to 7. All right, in letter H, I have another cubic function similar to this one. It just looks like my ends are going in opposite directions and we have some fun stuff going on in the middle. Well, arrows at both ends, big hint. Going on forever, going on forever. Going down forever, going up forever. So what that tells us is both our domain and range are negative infinity to positive infinity. And finally, we have another parabola and another another absolute value function. I hope we realize that these do have a minimum or a maximum point, but the domain goes on forever. So here, my quadratic function, which seems to have been vertically shrunk by a factor of 1/2, shifted right 5 and down 3, excuse me. Oh yeah, that makes sense. There's my vertex there at 5, negative 3. That's a minimum. So I guess while I'm there, let's talk about range because that is the lowest point this reaches. The range starts at negative 3. It's less than or equal to y, which is less than positive infinity. So it's going up forever. And my domain is always going to be the same for these quadratics, negative infinity to positive infinity. And finally, when I move on to example J, my absolute value function, again with these arrows going forever, my domain is negative infinity. Is less than x, which is less than positive infinity. My range, however, these arrows are both going down, but stopping up at this point. right there, which is a y value of 6. So we're going from negative infinity is less than y, which is less than or equal to 6. All right, guys, I hope you're super pumped to do more domain and range tomorrow in class. Oh, not tomorrow, Monday.